some point, to give you an idea, if you want to have a test for cancer, let's say, you cannot do it yourself. And even if you go to a normal hospital, it's really difficult for them to have the equipment to do it. Or in a pharmacy, they will not be able to do it. But if you have one device that can give you an idea if you have this disease, just by blowing a few seconds into the device, then you are a step ahead with this technology.
In diagnostics, this is well known for thousands of years. So people like Hippocrates, for example, was smelling diseases like tuberculosis, for example, by the smell, which was like stale beer smell, and diabetes, which is, sweet smell that the doctors know very well. But what we are bringing in this is that you make a digital IoT, the Internet of Things device, which gives you the automatic diagnosis tool, for detecting these symptoms.
Tervetuloa Vaasa Innovation Centerin tiedekanavalle. Perinteinen biologian sekä tulevaisuuden ja modernin korkean teknologian yhdistäminen mahdollistaa jännittäviä ja erittäin hyödyllisiä asioita. Yksi tällaisista asioista on terveydentilan seuranta ja sairauksien tunnistaminen verikokeiden sijaan esimerkiksi hengityksestä. Professori Risto Orava sekä elektroniikkaspesialisti Abraham Villator ovat kehittäneet HoloBiontech-teknologian, joka tarjoaa huippumielenkiintoisia mahdollisuuksia, eikä valtava terveydenhuollon kustannussäästö ole niistä ainoa. Mutta aloitetaan ensin perusteesta eli VOC:stä.
The starting point is that when you get a changing health condition, your system, your biological system will respond in terms of sending certain chemicals to your blood, and then the blood that circulates around your body in 60-second cycles, it will transmit these biomarkers, these chemicals, to your skin emissions or to your breath through lungs and so on. And these, in terms of what is called volatile organic compounds, these are gases which are easily evaporated. So these gases give you the markers of a given disease. More than 100 different diseases which have been identified in scientific research, to give you a certain profile, certain combination of these VOC gas molecules, which indicate the presence of a given health state. And the HoloBiontech, the basic task is to reconstruct these profiles, the combinations, the clusters of these VOC gases, which are uniquely defining the given health state. So that is the basic goal, the target of the device.
HoloBiontech-teknologian ytimessä on kehon kemiallisten viestien ja niistä syntyvien kaasujen yhdistelmien profilointi. Terveydentilan tarkkailu hengitysilmasta ja sairauksien tunnistaminen ajoissa ja nopeasti, mahdollisesti niiden ennaltaehkäisy, ovat hyviä ja tarpeellisia tavoitteita, ja terveydenhuollossa ne voisivat tuoda merkittäviä kustannussäästöjä.
I think globally the most important thing is that you want to catch any disease or any health condition which is risky for you as early as possible. So it's this preventive healthcare where one could gain globally, savings of hundreds of billions of dollars. Finland alone, we heard actually here today that one is talking about savings which are of the order of 700 to 800 millions per year in Finland alone that you could save by having more efficient preventive care. Now we are talking about the device which is very convenient to use, so non-invasive. You don't need to take blood tests, which many people are afraid of. It's said that 30% of the people don't want to go to blood tests because they are afraid of this. What we want to do is to have as affordable technology as possible, first of all. So you are using nanotechnology-based gas sensors as the basis for the array, which is actually detecting these VOC profiles, the clusters of VOC gases. And then the idea is that the device is cheap enough, to be in personal use, so that everybody could have one, like a pocket-sized device in the end, you know, like a portable phone.
I will say that aiming to this easy and fast and reliable test is the future for humankind. And I have great expectation on this breath analysis. And not only breath, we can actually jump to different kind of analysis, even sweat, skin, or intestinal gas, different kind of analysis that we can do. How far we can go, I know we can target several diseases. At the moment, we have at least 20 on the table that we want to address. But I mean, the potential is as far as you can.
Villatoro ja Orava ovat rakentaneet myös prototyypin laitteesta, joka mahdollistaa hengitysanalyysin. Se on helppokäyttöinen, kannettava ja myöskin päivitettävä. Käyttöliittymä on digitaalinen, helppo ja laite liittyy internettiin. Mielenkiintoisena yksityiskohtana voidaan mainita, että laitteen suunnittelussa on hyödynnetty myös fotoniikkaa, mikä mahdollistaa laitteen jatkuvan käytön ja tutkimusvaiheessa sitä on jopa käytetty suukappaletta vaihtamalla isollekin joukolle.
People are blowing into this device. You have a lot of high temperature, high humidity, and if you think about it, this is a nice environment for bacteria to grow. So you don't want that to happen. You don't want to have any bacteria or virus inside your device. So we implemented a disinfection system based on UVC light. So after each sample, after somebody blows into the device, we immediately disinfect the system for a few seconds of this UVC that we have some reflection chamber, and all of the device is clean in a matter of seconds, basically.
Mutta entä tulevaisuus? Hengitysilman kaasujen analysointiteknologian käyttöä voidaan laajentaa paitsi valtavan sairausmäärän tunnistamiseen, myös esimerkiksi elintarviketeollisuuden tarpeisiin tai kokonaisten rakennusten tai yhteisöjen terveydentilan analysointiin.
For the final user, what we are looking for is that they will have access to their own personal data. So you will have access, you can monitor the history of your health status. And so it's not only the current breath, but you will have, if you take, let's say, a breath every day or every 2 times per day, you will see the evolution of your system. So you can even track your metabolism on all different kind of things.
If you look at the non-invasive diagnostic tools now, the increase in the market is of the order of 10% for each application actually that we are talking about. We're talking about, you know, easily tens of billions of dollars, you know, for each application worldwide, you know, for the market. So, and this is all over the place. In fact, I mean, we are not talking only about people, humans, but also, you know, cattle, pets, and then also agriculture. So, for example, one of the things that they have been looking into is, for example, the storage of potatoes. You are losing some 30% of the potatoes because they are getting spoiled. How to spot them? You can use the same technology actually to spotting the spoiled, the rotten potatoes in the production. So it's the application field. Disease, health condition wise, you are talking about 100 different diseases. We have been doing feasibility studies for 20 or so of these so far.
Well, actually, yeah, this, if you look into the sensors that we're using, originally they are used for air quality monitoring. We are giving them a different use, but originally they are meant for that. So if you have a device adapted to a building or an apartment, you are able to find these kind of problems in very early stage, I would say. What we have discussed about, imagine that, okay, we are way in the future and you have managed to place this device, several devices per city. So you can actually spot problems in one city. Let's say that there is some problem, some contamination in the water, and some people will have some problems, health problems because of this. and you can spot them if you have the data. It's like, so not only one building, but even one city or a big area. You can do that. And even at some point we were talking about monitoring the health of your pet, your dog or your cat, and you can extrapolate that to the health of the house itself, like your children or yourself, because you are continuously interacting with this dog. So the dog will tell you some information about what is going on in the house at the end.
Professori ja keksijä Risto Orava sekä elektroniikkaspesialisti Abraham Villatoro esittelivät HoloBienter-laitetta Vaasa Future-festivaalilla elokuussa. Sitä ei kuitenkaan vielä haluta videolle asti näyttää, joten nyt odotamme jännityksellä, milloin laitteesta nähdään ihan julkisuudessa kehitysversio. Tässä jutussa kuitenkin kerrottiin kaikki tarpeellinen tausta tästä innovaatiosta, joka on siis olemassa olevaa innovaatiota. Kiitos katsomisesta ja kommentoi videon alle, miltä kuulostaa terveydentilan seuranta tai erilaisten sairauksien toteaminen pelkällä hengityksellä. Seuraamme aihetta ja lisää mielenkiintoista tiede- ja teknologiasisältöä löydät kanavaltamme muista videoista.